Okay, so here's the third video. Now this is on the sum and difference of two cubes. Now, in the last topic on quadratic equations, you heard about the difference of two squares, and might have also learned about why the sum of two squares couldn't be factorized. Well, it's a little bit different for cubics, and so in cubics we do have difference of two cubes, but also we have the sum of two cubes. And you can see the two rules for them on screen right now. Just here and here. Now, what I'm going to say is these are the rules for them, okay? And I will go into a proof of those rules at the end of this video, so, watch this right to the end if you want to see the reasoning behind these rules. But all I'll say is that the way to remember them is that the sign in this first bracket is always the same as the sign here. The a squared and b squared in the other bracket are always going to be positive. However, this sign here is always the opposite of whatever this sign here is. Okay, so that's how I've always remembered it. I'm going to jump into these couple of examples as quickly. Now you notice as well on the right hand side of the screen that I've written the perfect cubes. So I've mentioned before that I would expect you to know sort of up to 25 squared, or to at least recognize those numbers. And we also need to know up to 10 cubed. So I imagine that, a lot of these you could figure out fairly easily, but there's probably a few that are a bit more complicated. I think, when you're getting up to like 8 cubed, that's quite a high number, 512, but that's a really easy one to know because it's just a computer number. So if you're familiar with computers and how they work, then you would probably recognize the 512 there. Obviously 10 cubed is a nice easy one. So there should only be a couple of numbers there that you really need to commit to memory. Alright, so let's have a look at just factorizing these two problems quickly, and then we'll get into the proof. So x cubed minus 125. We need to recognize that 125 is 5 cubed. So this is also a difference of two cubes, so I'm going to use the rule just here. And so when I factorize this, I can see that a in this case must be x, and b in this case must be 5. So it's going to be x minus 5, and then x squared. Now, this sign is the one that's always different. And then ab, so it's x times 5, which is just 5x. And b squared is 5 squared, which is 25. And, well, there we have it. The quadratic part of that doesn't factorize any further, so that's quite nice, and that will always be the case with these questions. So you can, if you're unsure or if you want to question it, all I'll say is check the discriminant. Basically, the discriminant for this part will always come out to be a negative number, which means that it has no solutions, which means that it doesn't factorize. All right. So to do the other part of this, 8x cubed plus 343, so we need to recognize that 8x cubed is the same as 2x all to the power of 3, and 343 is 7 cubed. So I'm going to write this as 2x plus 7, and then I need to have the a squared, so it's 2x all squared, which gives us 4x squared. The sign here is different. Then it's going to be 2x times 7, and then plus and 7 squared, which is 49. Rightio. So that's our method for going through and factorizing these. So again, just if you were curious about what I was doing there, in this case I had a was equal to 2x and b was equal to 7. I think that's about as difficult as these questions get. So what I'm going to do now is I'm going to have a look at the proof for these two formulas. I only really need to prove one. So let's start off, instead of dealing with a cubed plus b cubed, what I'll do is I'll treat it as x cubed plus a cubed. So to factorize this, as we looked at in the other videos, what we have to do is we have to guess our first factor. So we want to guess something which is going to make this equal 0. Okay, so we're guessing a value for x. And I'm going to guess that it's going to be negative a. So, when I substitute that in, I get negative a all cubed plus a cubed, which negative a all cubed makes negative a cubed, plus a cubed, which equals 0. So because the negative a worked, therefore x plus a must be a factor. So now I'm going to write this down. X cubed plus a cubed equals x plus a. I know that's one of the factors, and so I just need to work out what the other factor is. I could do this using long division, but I think it's better to do it this way. So what I'm going to do is I'm going to build the equation up. Okay, so rather than breaking it down using long division, I'm going to build the equation up. Now at the moment I have an x right here. Okay, I need to get this x cubed. So I need to multiply this x by x squared. So x times x squared gives us the x cubed. I'm just going to keep track of what I've got down below, okay? But unfortunately that also means we have to multiply this a here by this x squared, and that gives us a plus ax squared term. Now the thing is that I don't want to have an ax squared term, because you can see in this left hand side of the equation there is no ax squared term. So I need to somehow make a minus ax squared. So what I'm going to do is I'm going to put a minus ax here, because this x here is going to multiply with this minus ax, and it's going to give us a minus ax squared term. But I've also got this a here being multiplied with it, and so that gives us a minus a squared x term. And again, we can see in this left hand side that there is no a squared x. So now I need to make a plus a squared x to cancel out the minus a squared x. So I'm going to put a plus a squared here. And you can see that when I multiply this x by this a squared, that's going to give us a plus a squared x. And I've also got the a times a squared, which gives a cubed. So you can see what's happened here now is I've got plus ax squared minus ax squared, so they cancel out. I've also got minus a squared x and plus a squared x, so they cancel out. And I'm just left with x cubed plus a cubed. So that's exactly what we need to do in order to prove that is the rule. And we can actually then really easily get the rule for x cubed minus a cubed. And that's because x cubed minus a cubed could be written as x cubed plus negative a cubed. So we're really just substituting a for negative a. And so if I substitute that into the rule, I'm going to have x plus negative a, and then x squared minus negative a times x plus negative a squared. And if I simplify that, that becomes x minus a, and then x squared plus ax, because minus minus makes a plus, and then negative a all squared makes plus a squared. So very easy to develop that second rule there. Anyway, I'll leave the video there and see you next time.